Awesome. So yeah, hi. My name is JJ Asghar. I'm a developer advocate for IBM. I don't know what that means either anymore. That was supposed to be a joke. Nobody laughed. Cool. I really do have the email address of awesome@ibm.com. If you know anything about IBM, yes, that is very, very unique and very, very hard to get. But for whatever reason, I found the right paperwork at the right time, and I got that email address. So you're actually in this room to be talking about an open source project that we created called Pete, or actually I created. I've learned trying to get to that space to be able to actually show it off. There's a lot of pre-knowledge you need to have. So I'm actually going to start a conversation here, and I'm going to shoot through this really quickly just to make sure that we're all on the same page. So when we get to Pete, you see the value of it, right? Because if I don't tell you the foundational knowledge you have, just looking at it, it's just another chatbot, right? And chatbots are cool, don't get me wrong, they're useful, but to see the real value of what we've accidentally created here, you can actually grow from it. And also the best part about this too is that to spoil it as a whole, how many are Django developers or Python developers in here? A couple? Okay. If you have any level of knowledge with Python or Django, you will be shocked on how easy it was just to glue all this together, which brings in really interesting conversations around extensibility and the ability to take it to the next step. We good with that? We're okay with that? Okay, cool. So I'm going to start the conversation of what open source AI is, because this all revolves around the concept of open source AI. And that didn't work. Why didn't that work? Why is that not working? Move slide. Slide's not moving. Hang on. Make that big. Make that big. What is... Okay, sorry, 2 seconds. No, it's not, like nothing's working. All right, hang on. Bear with me a second. It's really hard to show you a web app when the actual internet doesn't work, right? JJ Asghar. Bear with me 2 seconds, I'm so sorry. There we go. Okay, so first thing first, I do have a handful of QR codes throughout this presentation. If you wouldn't mind taking a picture of this, this proves to my boss I'm actually speaking to people. All it's going to be going to is ibm.com/granite, which is the model that I'm going to be talking about that we actually end up using underneath all of this conversation. Again, this just hits a counter. I'm not stealing any data or anything, but thank you for that. Again, it allows me to go out to speak at different events and engage with people on IBM's dime. Okay, so let's take a quick step into this space of what is an open source model. How many people consider themselves open source engineers? I mean, we're at Texas Linux Fest. Hopefully everyone's raising their hands. Yeah, okay. Yeah, so today, in the modern day, when you look at open source code, 9 out of 10 times you're going to go to GitHub or whatever and see source code, right? Well, if you didn't know, in the open source space with models, if you go to Hugging Face, who knows what Hugging Face is? Who does not know what Hugging Face is? Okay, actually we do have a couple. Hugging Face is basically the equivalent of GitHub for models. It's where you deploy all the open source models. When you go to Hugging Face, you pull down binaries. So it's not like going to GitHub where you can actually see the Python code or the C code or whatever and actually see how the thing is built. When you get an open source model, it is all just binary files. Okay, yes, you can get the weights and you can get some data sets, et cetera, et cetera. That's not 100% true. But in general, when you pull stuff down from Hugging Face, it's all binary files, and that's important to recognize. So the largest problem of it is that there is no source code. Right? When you look at it, how we've been taught how to use computers and how to engage in that space, there's actually no source code when it comes to this stuff. It's all just data, it's all just weights and measures, and it's all just binary blobs. And you can't decompile binary blobs to see how stuff is done, so that brings in some really hard conversations. luckily, IBM's coming together with the LFAI. Who knows what the Linux Foundation is? Who knows what the CNCF is? Who knows what the LFAI is? The LFAI is basically the CNCF version of AI for the CNCF that is for Kubernetes, if that makes sense. And they're both underneath the Linux Foundation. So they're sub-foundations under the Linux Foundation. LFAI is designed for the AI narrative. And they've come together for something called the MOF, the Model Openness Framework, to actually give a way for us to be an open governance on a way to give a rubric on how open your framework is, or sorry, your model is. So instead of some company, i.e. one out inside of Redmond or one in Silicon Valley telling you that it's open, AI, cough, cough, this one is a third party that is being worked with as a collaboration, so it has a little bit more validity, right? Instead of, corporations taking over the world. So it's very good. Obviously, IBM is deeply invested into it. We have the Granite model that's actually really high up on it because we've been working directly with them. And if you take a picture of that QR code, it really does go, is it open.ai? So if you take this stuff, you want to take this stuff seriously, I strongly suggest spending some moments with it. So TLDR of all that, just to make sure that we set on the conversation of what open source is nobody knows. That's the problem. We have the idea of this model openness framework, the MOF, and it seems to be gaining some traction in the community, especially with the LFAI behind it. But again, what's the XKCD? There was 14 different standards out there, so we decided to make 14 different competing standards, and now we decided to make another standard to standardize all those, and now we have 15 competing standards, right? That's pretty much that problem too. Oh, sorry, UT just went halftime. I'm a Longhorn, what can I say? Okay, anyway. So, fine, we talked about open source, what open source is and all that. In order to get into the model space, we need to start talking about a couple other little projects out there to make sure that we kind of get to the point of where where Pete comes into play. And this is actually really important. What is InstructLab? How many went to the Red Hat booth today or yesterday? Did you see this little dog anywhere? The Red Hat, the InstructLab? It's an open source project from Red Hat and IBM Research where it takes care of something called fine-tuning. Fine-tuning is the ability to add new knowledge or layer new skills inside of a model. So if you imagine a Docker container or a Podman container, and when you have to layer a new change on top of it, that's kind of what InstructLab does, is it layers a new amount of knowledge on top of the weights and measures inside of it. So it's an opinionated workflow to get to that point. If you ever spend any time in this space, there's a million different projects out there that does this stuff, and it's very kind of like choose your own adventure novel on that space. Unfortunately, InstructLab kind of came into this direction to be able to give you a one-stop shop to make it all work. It's all open source and great. And the original plan was to be able to run this on our laptops. With a Mac M3 like I have right here, you could actually do some relatively good fine-tuning. But as time has progressed and the ways the models have been moved towards right now, and I know I'm being recorded, so I shouldn't say this out loud, but please don't quote me on this. You need an H100 to do this now. And an H100 is a little bit out of our reach as normal humans. That's a $70,000 GPU. So unless you got $70,000 just laying around, we should talk after this. Just anyway. Thank you for laughing at that, by the way. With the work that we were doing with InstructLab, the idea was to create a rapid AI innovation cycle, right? Because one of the most important things to know about models, and this goes back to where we're going with Pete, is models only know about what they know, right? So the idea was we wanted to create a way that we could add new knowledge and new skills to these models in an open source way. So we could have like a real taxonomy that we can bring, kind of like if you imagine Wikipedia, but for models, right? So because when Wikipedia first started, people just started throwing human knowledge into it, and then we were able to edit it and kind of move forward with it and to be able to make it something great. Well, we wanted to use that same kind of principle with InstructLab to do that. Unfortunately, we couldn't find a way to incentivize people to come and actually do that work for free because it's an open source project. So it didn't really work what we were expecting to work with, but this was the dream. So there was something called Q&As inside of it to be able to do some simple questions and answers. Here's an example of one, just so you can kind of see it if you can. As you see, it's very straightforward. You give it a context of what you're looking for, and then you give it some question and answers. So remember back in like high school, you had that biology book that would have like a chapter, and then at the very end of the chapter, there'd be some context questions around what was going on in that chapter. That's the same kind of principle. That's how we learned how to actually start training LLMs, is that you give them some source material. Oops. That would have been really clever if I had been able to do it how I wanted to. If you do some source material, i.e. this guy, which is just a simple markdown document, and then you give it a bunch of Q&As, and then you push it through the InstructLab process, and it teaches the model new stuff. All of a sudden it says, oh, this is all the source material, I'll build a bunch of interesting questions around it, and then I'm able to take those questions and start answering them myself and retrain me on this new knowledge. It's really, really neat and a really awesome idea. Unfortunately, it requires a lot of hardware to do, and that's a different conversation for a different time. But again, why am I going through all this? It's because it's really important to recognize that in order to get to the space where we can start using models for medical knowledge and the ability to train professionals, we need to be able to pivot and change things when they need to. We need to add new information to them. And we need to find a way that, isn't just completely ran in proprietary ways. I mean, at Texas Linux Fest of all places, y'all understand, right? Like, if we have the Sam Altmans of the world or the Larry Walls of the world controlling this stuff, we're gonna have built-in biases, and we need ways to be able to do this in the open source way. So, as I keep going down with this, let's talk about who knows what a RAG is. Okay, cool. So imagine your AI is a librarian, right? Everyone knows a librarian's actually like sometimes a doctorate, but most of the time they're masters, right? They're actual master researchers. They're not just someone who takes your books at a library and puts them on shelves. They're actually very, very well skilled. And if you imagine your AI model as a librarian, the RAG is the library. So when you go up to your librarian and says, hey librarian, I need a book, I need to do some research on George Washington. They might know that George Washington's house was Mount Vernon, right? But they might not know the amount of ice cream he had there, because it turns out, if you didn't know, George Washington adored ice cream. And they might know the book to go find for it. So they'll go out to the library and find that book to bring it to you, right? Because they know that much. Fine-tuning would be the idea of adding that knowledge from that book into the brain of the AI or the librarian to send them back to school. So real quick right now, if you think about this for 2 seconds, what's more expensive? Sending a librarian back to school to learn new things, or adding a book to a library? Obviously, it's sending them back to school is significantly more expensive. But when you start really thinking about it at scale, right, when it's not just me on my laptop, it's me at IBM, how often is it going to be for me to spend resources to send my librarian constantly into the library finding books and all, and then bringing them back to the responses, compared to me just sending them back to school to get that new knowledge that they need? So there's a give and a pull on how many resources you need to do, and think about the scale of how you're going to use that LLM to be the difference between using a RAG and hitting that database over and over and over again, compared to taking it offline and spending a weekend on renting a H100 to do some fine-tuning. You with me? Does it make sense? So on the laptop, playing around on your laptop is cool and all, but when you start looking at it from production, you start really thinking about really hard problems here. So in the space Obviously, we need to talk about agents and agentic workflows. And all an agent is, if you don't know, is just a Python file. Thank you for laughing. Thank you for laughing. But I do need to talk about some frameworks. So there are 3 main frameworks out there that at least I acknowledge from the space that I go into. B framework was started as an IBM research project. Obviously, I pay a lot of attention to that one. But we recently donated it to the LFAI. How many Node developers are in the room? Any Node developers? Okay. Well, obviously, this is a Python talk, so hopefully you're Python developers. The interesting part about B framework is that it's all written in Node, which is really unique when it comes to the AI space. Crew AI has become kind of the de facto standard when it comes to the frameworks out there. That video right there, I have a link in this, is phenomenal to teach you about how to use agents on your laptop to get things done using Crew AI. I'll have a link to these slides here in a little bit, and it's a direct link to it. It is 4 hours long, and it's free, but I learned more about agents than I could have through that. And then AutoGen still exists. It's from Microsoft. Nobody cares. So let's talk about actually what model we should tune. So when I was talking about Hugging Face earlier, if you look at from March 10th, 2025, I looked at how many free open source models were on Hugging Face. That was 1.4 million. Do you want to see how many it is right now? Just out of curiosity. Let's take a look real fast. Hugging Face. Excuse me. Models. Oh, look, that's 2.1 million models that you can download from Hugging Face right now. You know when your boss used to tell you, hey, don't take things down from GitHub because you don't know where the hell it came from? At least you could see that code. You pull any model from Hugging Face right now, 2.1 million different models. You have no idea where any of this comes from. It's very possible some of these models have inside of it, kill all humans. You have no way of knowing until you use it, right? If you want to build this for your business, it's kind of a big deal. So that brings us back to Granite, that original link that I had out there. Obviously, I work at IBM. Granite is our open source model that is a family of models to kind of do stuff. We have multiple different ones, and we're going to talk about the Granite 3.3 model today. Actually, I just converted to Granite 4 as I was waiting for the previous talk. There's also Granite Vision, Granite Guardian embedding, time series, and Granite Code. So Granite 4.0 is our inference model, kind of like the one like ChatGPT, the one you talk to. Granite Vision has the ability to look at charts and graphs and gives you information from them. Granite Guardian builds up some borders, or not borders, but checks and balances for responses to make sure, like HAP isn't a problem with it. Granite Embedding is the way that we do our embedding model for RAG. Granite Time Series is actually one of the more interesting ones. It does really interesting projections and data around time series data. I have some interesting use cases with that one. And Granite Code is basically our version of Copilot or Claude. The most important part about Granite Code, though, is that our model and all of our models are completely and utterly open source, attributed correctly, to the point where we will put our lawyers in court to say that we can give you everything that we say that this is not, there's no licensing problems with it whatsoever. All of our models are Apache 2 licensed, so if you worry about the enterprise story of using one of our competitors and them stealing the information from the rest of the world, I don't know, there might be a company that might be torrenting every single book ever written and using it to train their models. We, on the other hand, have actually we have data engineers working through our data sets to make sure everything is attributed correctly and works the correct way. Admittedly, we're not as great as our competitors, but if you think of it this way, they're Napster, we're iTunes, right? We're leaning on the story of using models to benefit society, and also all of these run on your local laptop too, which is important. We're not boiling the ocean when we do the work we do. And also, as you can see, we believe in one job well, the old Unix philosophy, compared to our competitors who has one big model that does everything, that requires nuclear power plants to run. And we can just run any of these, as you'll see here in a moment on my laptop, and be able to get more or less the same performance out of it, which is really cool. Okay, so let's talk about some use cases, kind of set the play, and we'll get to Pete here in just a second. First thing first, one of the neatest ones I ever used, I'm an organizer for DevOps Days here in Austin. If you know what DevOps Days is. I actually built an abstract classifier because we get about 200-300 abstracts a year, and it's really lame to get a sales pitch put in there. So I wrote an LLM to check and give me a percentage of how possible it is a sales pitch. And it sucks having someone on stage talk about a product they use all the time. Oh, whoops. Anyway, but it's actually really neat, right? Like, we were able to get some really cool kind of ways to bubble the stuff up. We still have a committee and all that jazz, but it allowed us to deprioritize some abstracts out there that we shouldn't be paying attention to. And it was fun, right? It made our lives a little easier. This is the one we're actually here to talk about, which is using to do medical students motivational interviewing. Who knows what motivational interviewing is? Okay, cool. So motivational interviewing is basically one class that medical students go through their whole career at med school. They bring in actors to sit down with them, and the actors have a book in front of them or a sheet to say that they have this problem, and the medical students are supposed to ask questions to kind of get the answers out of it. It's kind of to role play, right? Well, unfortunately, this is one class out of possibly 10 to 15 years to teach them how to ask questions and engage with humans as a way with a certain amount of knowledge. So what I ended up doing is I ended up throwing Django in front of Olama and took their motivational interviewing sheets of information and did some prompt engineering to kind of give me a way to interface with them. And then in turn, excuse me, now I can give this to the students, where granted it is through text, but they can at least ask questions and engage with a fake patient to figure out what the problem is and to work with them. And I'll show that to you here in just a second. Here's another one. So I'm a dad. You can see my daughter in the background very angry because I'm at a STEM night trying to show something. We were on our way to softball practice at that time, and she was just on her phone because that's what a 14-year-old girl does. But I was at a elementary school STEM night, but what I ended up doing is, if you look here, I used Granite to write me stories about what this little boy really liked. And we're in Texas, and so of course he likes football, right? So I got Granite to build me a story about football, and then I pushed it through a vision model to give him a little image of that. He was like, oh, that's cool, whatever. Well, it turns out this is the dad was standing, not this guy, but dad was standing about right here. He got super excited because all of a sudden he realized he could now use Granite to write that princess story that he told his 3-year-old every single night, and be able to continually write a new story so he doesn't have to say the same story over and over again, which is really neat. And then he was able to push it into the vision model to get a picture of what that princess was doing, and it was actually a really kind of interesting way to create new stories and change things around and really, really engage with his kids. So the kids didn't care about the STEM stuff, but the adults, or the parents absolutely loved the storytelling part. So there's 2 ones here that I want to talk about, the Granite time series model. So I'm a type 1 diabetic. I have the luxury of an insulin pump. You might have heard of beep already once. Oh, blood sugar's pretty high. So what I've ended up doing is, part of my job is I go out to conferences and I speak a lot. So I have to take a bunch of stuff with me when I go as a diabetic. And I don't actually know how much insulin I'm going to use because it could be many different reasons. Well, what I ended up doing is I used the time series data, my data from my sensor right here, excuse me, and I projected it through the time series model, and it gave me a projection of how much insulin I'm using over time. So I was able to, I'm starting to build a system to be able to tell me how many vials of insulin I need to take, how many new infusion sets I need to take. So instead of me taking like 30, not worried that I'm going to need all 30, now I can actually kind of gauge exactly how much insulin I need to use and all that. And it's through the actual time series model, which is fun. So I was actually at Nagios WorldConf earlier this week, actually, and I actually got the time series data to push through a bunch of Nagios logs where I was able to actually show off projections of disk usage and load average on a machine over time, which was kind of fun. That was pretty neat. It's a nice little use case. Okay, so hopefully kind of see that all these different models have kind of different strengths and different weaknesses. So let's go back to Pete real quick. So Pete here, as I said, it was just a Django app, right? So I'm just going to run the Django app right now. And then I will do this. And this is Pete, right? So hang on. So as you can see here at the top, I use something called Faker, which is a module inside of Python, where it just creates basically a bunch of random different people, different names, with a job and an age. And I can be like, hey there, Nikki. What brings you in today? And this is all local on my own laptop. Oops, that is a little too big. Why is that not making it small? So Pete was because I originally called this project Troublesome Patient, and I was told by IBM Marketing to change that name. So as you can see here, this is the Granite 4 model that took from our little statement. And then as you can see, it has a bunch of nice conversations around what's going on. And again, this is just me kind of playing with it, right? Like I'm just kind of art of the possible here. But the idea is that the students can start interacting and start working with it as a normal person. Also on top of that too, I have pediatric profiles. So I actually got kids in here too, which will have speak like Gen Z or Gen Alpha or whatever if I need to, because it's just prompt engineering, right? Like I just change the prompt around a little bit so they engage in that space. And if you take a look at these adult profiles, that goes back, as you see, it's a new one right up there too. And then on top of that too, there's the tutor inside of this. And what is the tutor? If you log out this chat into the system, which is really, because it just naturally does it, there's a rubric for motivational interviewing that can come back. And if I believe I have one in here, let me see, give me 2 seconds. Bear with me, I should have had this propped already. You get to see how my brain works now. Previous chats. So there we go. This is Ronald Chapman, 37, a commercial residential surveyor. I upload it in here. And it should, don't make a liar out of me here. Why is this so big? There we go, that's better. No. Oh, boo. Okay, well, you know, open source software sometimes breaks, right? The idea is that when you were supposed to upload it, and I guess I was embarrassed to not be able to get that fixing. It goes to the rubric and actually goes through the chat to figure out what was going on. If you want to take a look at this is the actual open source, the actual project here. All is required on the machine is Ollama or Podman Desktop or Podman Compose to get it all running. You pull down the different containers on it, and then as I said earlier, it's just basically just Django in front of it. Real simple, straightforward. If you've never played with Ollama before, I strongly suggest taking the moment to do it. You can run more or less every crazy model you can think out there for free on your own laptop, which is really nice. It's written by the same people who started Docker, so it's kind of got the same workflow. So you do Docker pull, or you do Docker pull, Docker run, you do Ollama pull, Ollama run, which is fun too. But again, as I was saying earlier, that they are just binaries. So when you do go to Ollama, you do need to pay attention to the models here. So compared to Hugging Face, which as you saw was 2.1 million different models, those are the safe tensors and the binaries that get them. Ollama has a little bit of level of, not certification, that's the wrong word, but there's at least a human in the way of these releasings of these models. So there's more on the businessy side, but at least you know that they're not going to say kill all humans, which is important. As you can see, you have access to the GPT OSS out here, DeepSeek, and whatnot. Just as a plug, because I need to, because I work for IBM, our IBM models are all on here too. And then we just released the Granite 4 model. Where the hell is Granite 4? Right here. This one, you might have seen a couple posts around it if you're big into the AI space. This Granite 4 model can run with the web GPU in your browser. And as one of the micro models, it is the highest performing at the moment. So it is really, really good, surprisingly. Okay. So all of this conversation, JJ, like, that's cool. Like, maybe I do actually want to play with this stuff. First thing first, if you actually want to get this working on your laptop right now, if you go to this workshop, this QR code, all free, open source, it'll walk you through getting Ollama working and a few different interfaces with it, from the soup to nuts. We did just upgrade it to Granite 4 also, so it'll install Ollama on there, anything LLM, open web UI, and actually interface with the model in a pretty useful case. If you're more on the developer side and you want to figure out a way to push Granite into an application you might have, these is called the Granite Workshop, which is basically a bunch of Jupyter notebooks to interface with Python to talk to the model. If you're, like I said, if you're more on the developer side, this is closer to what you're looking for. Excuse me. And then finally, this is a QR code to this actual presentation. It's all on GitHub, and all the links work to different videos and whatnot. You're more than welcome to steal, use, whatever you want. And that is really, truly my email address. So if you ever have any questions or just want to shoot the shit, you're more than welcome to reach out to me. My job is to be accessible. Hopefully you learned something. Thank you so much. Any questions? I'm a Pisces. Yes.
You said you worked with RAG basically for the application you showed. Have you worked with fine-tuning much?
So the fine-tuning path I went down was InstructLab specifically. Oh yeah. So the question was, you've been using RAG to do that kind of work. Have you actually fine-tuned a model to have some of that stuff inside of it? My original plan was to actually fine-tune. My original plan was through InstructLab to kind of give that new knowledge of the motivational interviewing rubric into it. But I discovered that the Granite model already had the rubric already inside of it. It turns out it's a very standard process in the medical spaces. So I didn't need to fine tune anything into it. I just needed to basically do some prompt engineering to manipulate the model into thinking that it was an 8-year-old boy or a 35-year-old train conductor, and then just kind of work through that with the randomized, what's I'm looking for, ailments that the patients had. So then the doctor, or I guess the medical student, could ask the right questions to pull that information out. The one I showed here a moment ago was a very bad example. Normally it's much better about that. It really truly is. I don't know why that one went off the rails. But that's another problem with this project, is that it's just me kind of fucking around with it, right? So if I had more people looking at it, we could probably kind of keep those, that conversation's a little tighter. Did I answer your question? Cool. Any other questions? Oh, hold on.
Hi. Is there a schedule for the release for the models? Is that like released every year or something like that?
Great question. The short answer is no. You'll quickly recognize that when you start playing in the space of open source models, especially like an Olama or the major competitors out there, models come out pretty rapidly because this industry, or this space of the industry, is rapidly changing. One of the advantages that IBM's playing on is that, no one ever gets fired for buying IBM, right? That's that old adage. And what we've done is we're a little slower than the rest of the industry, mainly because we're trying to build iTunes. And we're trying to be safe and the enterprise narrative, that an enterprise can slurp in for free our models and be confident with what we're doing. So we're not, like, we released Granite 3.3, which was the previous one before Granite 4, back in April, ? And then Granite 4 just came out with a brand new architecture, but we were working on Granite 4 when we released Granite 3.3. So it's because the way this stuff moves so quickly, and the innovations of actually how the brain, if you will, is, we're always moving forward, but we're just a little bit more conservative with our release schedule. Did I answer your question? Okay, cool. I'm also an umpire for 10 to 14-year-old girls softball. I actually was doing 2 games before coming here. That's the reason why I'm a little tired. Just my legs are killing me, I'm not gonna lie. What else?
I'll try with a weirdly specific question, perhaps. I'm totally new to the LM stuff, so I'm trying to build some intuition. I live in El Salvador, and where I live locally, there are some books with local heritage health information, like typically the health benefits of eating this animal or eating this plant, blah, blah. And one of my ideas was to try to understand the SLM, I guess, space more, would be to take the most minimal model I could do and then add this information to it and query to see if it absorbs it. Now, the question, I guess, is, you say it's very hardware intensive or computationally intensive to retrain them, but is that true in all cases, or is it just the LLM thing? I don't know if that question makes sense in any way.
100%. So first of all, El Salvador is Spanish, yes? Central America.
It's Central American.
It speaks Spanish.
Whatever.
Okay, just making sure. Well, first of all, just to pitch Granite, it speaks Spanish, which is good. It speaks Spanish. It does not speak Portuguese. That's because I have friends in Brazil, so I wanted to make sure I got that right. So the specific knowledge you're looking for, that is actually a perfect situation for a RAG, right? Where it has that database that it goes out and finds that information to. And then at some point, if it needs instantaneous response of that stuff, then that's when you look into fine tuning. the model to add new knowledge to it. But the problem is that as soon as you fine tune that one model with that information, then you're adding to that 2.1 million models out there. Because now that binary only has that new knowledge inside of it. Because you can't it's a one entity thing. Does that make sense? Where if you have a very stripped down model that talks to a RAG, that RAG becomes the central point of knowledge, and you can add whatever model from that to talking to that RAG. Does that make sense?
That makes total sense.
Yes.
So let's say my motivation is to keep it local. I don't want to upload it anywhere. I want it to do just that.
Yes.
Now retraining it or fine-tuning it, what am I looking at? Like a weekend doing that on my laptop? Can I even do it? I have no idea.
If you wouldn't mind answering through the mic, what is your machine in front of you right now?
It sucks because my previous one died on me, so it's a Lenovo something.
Is there a GPU inside of it?
Yeah, it's like ostensibly a gaming, budget gaming laptop from Lenovo.
How much RAM does the GPU have?
I don't know.
8 gigs, 9 gigs, and 6, 8. Well, okay.
Anyway,
yeah.
Say it's 8.
8 gig. That's about a month to 3 months worth of training time. Dead serious. And you put in, that's the problem with fine tuning is that as we've learned through the Instruct Lab project, the reason why I bring it in here is that if you have something like an H100, again, that's a $70,000 GPU.
Actually, on UDAC it's $31,999.
Oh, that's right, because an H200 came out. That's right. You got me on that one. The machine to run it, anyway. But the challenge is the amount of hardware to do fine tuning can be cost prohibitive for normal humans. For a corporation, it's a different story. But then all of a sudden, you're talking about a corporation level of scaling, and that brings in that conversation of should you just have a RAG of all this information? And that's also where this embedding comes into play. And if you were here for Major's conversation earlier, he mentioned something called Dockling out there, which is a project that converts flat text to ways that LLMs can actually interface them for really useful things. So we have ways of being able to basically give you the Lego bricks to build the castle that you want, but it's about how much effort and time you want to put into it. But from our conversation, and just as I'm recording to answer your straightforward, I would strongly suggest scanning those books into some level of PDF out there, and then use something like Dockling to convert it into Markdown, and then put it into a RAG. Oops, that's not it. Bear with me 2 seconds. Come on. This workshop right here will teach you how to have a RAG locally using with either anything LLM or OpenWebUI, and then you can actually see and work with the different models out there to work with that RAG and be able to experiment to get the right questions out of it. That to answer your question directly.
That is fantastic answer. Just one more question then.
Sure.
So if it was that tiny, I guess,
yep.
And with this GPU, what would I be looking at then in terms of time? Still weeks or?
To do the fine tuning or the RAG?
No, the fine tuning, yeah.
Yeah, it would be. Yes, still. The way it does that stuff is as someone who attempted to do this, I was able to do Instruct Lab fine tuning on my Mac M3 this time last year, and it would take anywhere from 6 to 14 hours, but that was also with nothing else running on my machine, and a very high, like a $3,000 computer, right? With the models they are now, back to our question about how you release and how often you release, the architectures have changed so drastically just over this last year. They're even more complex. They take even significantly longer. And you need to have even higher hardware to be able to do the fine tuning. So you basically start looking at the RAG all over again because I'm like, I need this knowledge. How do I get this knowledge in here? I can't sit here and just send that librarian back to school to give it new knowledge. I need to basically let the librarian find the book inside the library. Does that make sense? Cool.
Actually, I have one more if there is no, I don't want to hog all the time.
Those are great questions.
So, thank you. So on that note, is there an argument for doing like this, what is called the 6510 sort of, the Commodore chip, 64 chip? Like, let's say I don't want the complexity and the novelty then. Let's use the librarian from 5 years ago, and I'm totally content with that. From what it sounds like, that's now a feasible scenario, and is there any merit to that kind of thinking?
So this is more on my personal opinion now. This is JJ speaking, not as an IBMer. This is me speaking as a nerd who tries to spend my time to understand this space. Nice to meet you too. One of the largest challenges, and one of the things that I know as an industry we made a mistake doing, is that the major players out there hit the market way too early. The ChatGPTs, the Geminis, frankly, the Alexas and the Siris hit that market too early. Why am I saying that? Because the open source community immediately started building their own open source models, but there are no fingerprints. All of these binaries, you have no idea where any of the pedigree comes from. And that's one reason why Granted is so important, is because IBM's willing to back it. And we have ways to prove that that is one of our models that we can say for your enterprise, that's a really cool thing. But you go to Hugging Face, there's no way to know what that is at this moment in time. So over the last 2.5 years, all those 2 million models are out there and you have no idea what's going on. So if we go scoot forward 5 years now and come back to today, there's no way for us to prove any of those models are anything. Like, because it's, again, it's a binary blob. When you actually look at it, it's all just ones and zeros. MD5 sums can't get you very far. As we know, MD5 sums is a terrible way for us to verify things, right? And there's no answer to this. There are some projects out there to try to create some fingerprinting, but it's way too little, way too late, right? Like, maybe in the future, going forward for a couple things here and there, but there's already enough models out there that have every single Dungeons and Dragons book already inside of it. There's companies out there that might start or end with book and then start with face that have stolen every single book on the planet to train their models. And that's already out there. And we have no way of knowing. You could just change the file name, right? And all of a sudden, it could be called, you know, JJ's awesome model, and there's no way to know. Piracy is ridiculous in this space. Did I answer your question? Absolutely. Cool, thank you. And I think I'm about to be kicked off, so if you have any more questions, I'm gonna be going over to the expo hall, so you're more welcome to stop me. Otherwise, thank you so much for being here.